My name's Don. Welcome. I appreciate you stopping by. I'm going to be talking to you about designing intelligible paging systems, and that includes emergency communications as well. So our agenda today will be a quick overview of 70 volt, factors to consider when you're building a system, some typical office warehouse setups, more comments about designing a system. We'll be looking at what STI is and what you should be looking for with that, how you can achieve that. A couple of application examples, and then we'll also touch on emergency paging at the end. So, paging, sometimes different people talk about paging in different ways. They might call it intercom, they might call it paging. Paging's that one-way communication. When I want to contact everyone in the facility, that's paging. And when you're putting together a paging system, there's a lot of factors that you have to take into consideration. Usually in paging systems, we use a 70 volt system. So when you're thinking of what's 70 volt, 70 volt is a high impedance system used for larger systems like a paging system. It could be 100 volt, although that's mostly used in Europe. We are primarily 70 volt products and systems, but you can use 25 volt. Often I see that in schools. So you might see 25 volt there, but these are all high impedance, and more often than not, we call it 70 volt just as another short way of talking about it. The 70 volt speakers have adjustable tap settings, so you can see the bottom left-hand corner. There's a diagram of a tap, and you can, using a screwdriver, you can turn that switch to whatever tap setting you need, and it raises, usually steps up in 3 decibel increments. Amplifiers are high voltage, high impedance outputs. They're delivering a constant voltage, so you don't have to worry about, with 70 volt, you don't have to worry about speaker loads. We'll talk about that in a bit, and speaker loads and affecting how the other speakers are behaving because of one speaker. And they're usually 70 volt is used for distributed systems like paging systems, but in other ways as well. When you're hooking up a 70 volt system, if we were to make it as simple as possible, this is how 70 volt speakers are connected, sort of like light bulbs, positive to positive, negative to negative, going out in a string. And really the only thing that you have to think about when you're putting together a string of speakers is the wattage, the total wattage that the speakers will demand. So if you have a number of speakers on a line, and using that transformer switch that we were looking at earlier, if all the speakers were tapped at 1 watt, there were 20 speakers, that means the total demand would be 20 watts. So as long as your amplifier has 20 watts to provide, you're good. And really, when you're selecting an amplifier, we'll again mention that later, it should be more, the amp should have more than just the bare minimum. You need to have what's called headroom, and that makes sure that the amplifier is not working too hard and it has a nice long life. But as long as you have an amplifier that can provide what the speakers are set at, you're good to go. Some advantages: they're all connected in parallel, the speakers, so there's no series wiring required. Sometimes when you're working in low impedance and you're trying to put speakers across a zone, you're thinking about what's the term, the magic box, or the number of speakers, 9 speakers, and there's none of that. You don't have to worry about that. There's no need to be constantly checking the impedance with a meter. If one speaker fails, in one zone, there's 20 speakers in that zone and one fails, that doesn't knock out the zone, which is what would happen if you were wiring it in another way. With high impedance 70 volt speakers, that speaker will fail, fine, replace that speaker. Everything else will continue to work, which is a big benefit. Power taps on the speakers, as we mentioned. So one speaker could be tapped at a higher tap setting. If you have particular ambient noise is really loud in that one area, maybe 1 or 2 of those speakers will need to be tapped at 5 watts instead of 1 watt in order to have understandable announcements in that area, you can do that. Just as long as you have the amp that can provide that when you add all the speakers up, right? As I said, removing speakers doesn't bother it. You just have to consider the length of the line. You have to consider the gauge of your wire to make sure that the signal is going to run as far as you need it. And you can just have simple volume controls, very similar to this setup here. You've got your two sources. You've got the microphone and the background music going into this 70-volt amp, and it's putting out that high impedance speaker line. But you'll notice that in this diagram, there's also a speaker line that's been branched off, and there's a volume control, there's a volume attenuator in between the speakers in that second lineup. I used to do this quite a bit when I was working with an integrator for restaurants. The dining room usually just plays nice background music, not like the bar where they're playing the TV or something. This is just music. So I would branch off from the dining room and use that feed for the washroom. So there's nice music in the washrooms. You could use the volume attenuator to actually bring down the volume. You can't go any higher than what the dining room's at, right? But you can bring it down. And usually that's a good idea because dining room volume in a small washroom is actually pretty loud. So you'd actually have to dial it down. But that's how you can do that. And that's the convenience of 70 volt. We actually have a downloadable form that you can use so that when you're talking to your customer, you can just write down all that they're requiring in this system. Write it all down. What do they need? Do they need backup music, background music? Do they need a microphone to page, or are they paging with the phone? What are the dimensions of the room? What's the ceiling height? That's a big one that we need. You can take all that information and email it to me or whoever your rep is, and we'll forward it to our design team. We can use all that information. Plus, if you have pictures, if you have floor plans, wow, fantastic. We can put all that together, and our team can get together and put a design together for you and for your team and for your customer, and have a bill of materials, and we can do that. So here's some things that we have to think about when we're doing that. And you can think about it as well if you're putting together your own 70 volt system. What am I paging into? What's the zone that I'm paging into? Is it a huge space like a warehouse that you see in the picture, or is it a small room? Is it just a number of small offices? Is it inside? Is it outside? That's huge. What are the surfaces in the room? Is it a lot of concrete, or in the offices usually there's furnishings and carpet and all sorts of stuff? What's going on in the space that we're paging into? What's the ambient noise in that space? If you're paging into an office, it's usually not, there's not really too much going on other than people talking and the photocopier, and that's about it. But if you're paging into the warehouse, well, depending on the space, there's a whole bunch of forklifts driving around, or there's actually some manufacturing happening and the machinery running, that raises the level quite high. And if you have a very low system in the warehouse, nobody can hear it. It's just adding to the noise. It's useless. So you have to think about ambient noise. Then you have to think about the speakers that you're going to be using. If it's an office with a closed ceiling, a T-bar tile ceiling, you're just going to use ceiling speakers. If it's an open ceiling, maybe you're going to use pendant speakers. If it's a warehouse, depending on what we just talked about already, you're going to use horns like the one pictured here, or horn arrays, depending on the size of the room. You have to think about angles and the sensitivity of the speaker, the distance that your listeners are going to be from the speaker, frequency response of the speaker. So all sorts of different things that you have to think about. And then you have to, if you have your speakers narrowed down, you should also be thinking about what kind of amplifier that you will need. Is it 4 speakers in a dentist's office? You're not going to need that big an amplifier, really, are you? You're going to need just enough for the power for those speakers. But, depending on the top setting, what you've set your speakers at, that will determine your amplifier. Plus, when we're talking about, I spoke about wiring gauge. We actually have, if you go to our website, there's actually a really nice chart that we have on the website. You can see just a clip there. It talks about the wire gauge, the length it'll run, if it, how it drops off, signal drops off over distance, what you're going to be using, that type of thing. So for in a traditional 8 ohm system at home, home stereo, you probably got some monster cables, right? Maybe 10 gauge or something like that. Like they're thick monster cables, and there's 2 speakers and your power amp, and you're done. With distributed systems with 70 volt, it can actually be a much more narrow, a much smaller gauge cable. I used to use 18.2 FT6 everywhere because you could run it for a great distance, far longer than I needed. And it had that that fireproof, not fireproof, but the fire jacket, the FT6. It's just what you need. Do you need signal processing in this paging application? You obviously don't need a lot of low end. You don't need subwoofers or anything like that if you want intelligible announcement, because low end doesn't really help with speech. It's more in the higher range. But maybe you need some sort of compression, some sort of filter, high pass filters, different things like that. Maybe you need an ambient noise controller that will automatically raise and lower the volume of the announcement to match the ambient that's in the room. That's something that we can provide as well. What type of sound sources are required? So are they paging, as I mentioned before, are they paging with a mic? Okay. Are they paging with a phone? That's fine. Is it the old analog PBX or is it IP VoIP phones? Will there be background music? If so, what is it? Will there be tones for announcement? That's something that could be brought up. Maybe. Sorry, I just got distracted. So tones for maybe signaling lunchtime, shift change, different things like that. That can be included. The TT104B is our timer, and it can be set up. You can set up a schedule in there to trigger a digital message repeater like the EV20R, which can play messages or tones or little music or something like that at certain times. Does the fire alarm, does the fire code or the authority in the building require that if there is a fire alarm, that everything else mutes? Okay, that's fine. We can do that too. So now that we know all of that, we have to think about sound and how we can reach the people that need to hear the announcements. And so you have to sort of think about sound pressure levels in decibels, and we have to think about what we're paging into, what decibels do we need to be thinking about. You can see some references there about different decibels and what that means, just to give you an idea of how loud it needs to be. So you need to think about that and where you're going to be putting the speakers into. So to do that properly, we need to look at the type of speaker and its sensitivity. This is a good way to compare speaker to speaker. It sort of puts everything on an apples to apples kind of comparison, so you can understand 2 speakers from different companies. What's the sensitivity? This is one way. The particular speaker that we're working with puts out 90 decibels when you power it with 1 watt, and the listener is standing 1 meter away from the speaker. I am hearing 90 decibels. Well, when you change, if you need to hear more, if you need it to be louder, you would need to apply more power. And to increase it, every time you double the power, you'll increase 3 decibels. So if I wanted to have it higher than 90 decibels, I would apply more power. So I would double it. So it's right now at 1 watt, it's 90 decibels. 2 watts, 93. 4 watts, 96, 8 watts, 99, and so forth. So we need to keep that thought in mind. And then we proceed to the next thought. How far is the speaker from the listener? Because every time you double the distance, it drops 6 decibels. So if you double the power, it goes up 3. But if you double the distance, it drops 6. So you got to sort of go back and forth here. And so if I'm in a warehouse, typically the horns they're pretty high. They provide great coverage, but they're pretty high. So they need to be considering how high should I be setting the top setting on that speaker so that Don can hear the announcement. So I have an example here. This is using that speaker with the sensitivity that I talked about. We're going to mount this speaker at 6 meters high. Now, my ear level is around 2 meters, just to make things simple. So that means that the speaker is going to be 4 meters away from my ears. So if we want to think about how the sound will drop, so 1 meter away, remember, it was 90 decibels. But if you double that to 2 meters, now it's 84. If you double that again, it's going to be 78 decibels at 4 meters away. Now, I've taken the ambient, and the design says that I need to have, my listener needs to be able to hear at least 84 decibels in order to understand the announcement. So what does that mean? That means that we have to start doubling the power to that particular speaker. So remember, at 90 decibels with 1 watt, 93 decibels at 2 watts. So if it's in the example here, it's at 78 decibels right now. So if I double the power, it's going to be 81, and then double the power again to 4 watts, it's going to be 84 at my ear level. So that's perfect. So there's no particular top setting that has 4 watts, but there is a 5. So I'm going to top all these speakers at 5 watts. All right. So now we know the top setting, but you also have to think about the axis. When I'm standing in front of that speaker at 90 decibels, 1 watt, 1 meter away, I'm directly in front of that speaker. But if I happen to go to the left by 30 degrees, whatever that measurement happens to be on the ground, if I happen to go, it's going to drop 6 decibels just as if it was moving away from me. So I have to also think about how I'm going to space my speakers. And so I want to make sure that my speakers are far enough away that I'm covering the area nicely without too many speakers. But at the same time, I don't want my listener to be walking through the warehouse and going from coverage to no coverage. So if you were providing background music, I hear the music, then the music drops away. Then, oh, now I'm walking into it again. I don't want that. So you have to make sure and measure to calculate the spacing for the speaker so that the listener is always walking through coverage. Imagine those cones coming down. They have to be blending together so that wherever my ears are, I'm in a covered area, and I'm always going to hear the announcement. So you have to take that into consideration. So now we're going to calculate the amplifier. I needed 19 speakers. Remember, we determined it needs to be 5 watts. Well, that means 95 watts. Here's that rule of thumb that I talked about, adding 20% for headroom. That way the amplifier can work, but not work too hard, and have a proper lifespan for that amplifier. So I'm going to add 20%, which brings it up to 114 watts. So TOA has a great line of amplifiers at 120. So that's great. That's great for this particular case. So now you've got your 120 watt amplifier. Perfect. STI. If you work on projects, tenders, different things like that, sometimes the engineer will put that an STI level has to be met with the paging system. So what is that? This is the speech transmission index. I'll try and say it properly. And it's measuring how well you can understand an announcement. So the values range from 0 to 1, which is sort of weird. 1 being the ultimate and 0 being terrible. So now most often the STI will be shown as a point something. Maybe in a tender, the engineer will say it has to hit 0.6. Okay, so that we have to think about that when we're designing as well. This intelligibility can mean a lot of different things. SPL, sound pressure level, the ambient noise I talked about. So then the surfaces, if it's a lot of hard surfaces, you got to think about reflections, reverberation, the distortion, things like that. And you know, when you have it right, you can understand it. But if you have all these other things influencing your announcement, it can make the announcement just mud. So you really have to think about all of these different ways to adjust for the STI. It's measured with this device here, and you can see we've got a reference guide. So on the bottom left, you can see that 0.6 to 0.75, that's good. That's good intelligibility. If you look at the right, the chart on the right there, 0.6 D, you see that band D going up, so it can be as intelligible as a classroom, up to, you know, a recording studio, which is the ultimate. So if it's 0.6 or better, that's what they're looking for. You can see here, excuse me, you can see here that the third point, there's an example of something that came up in a tender. The installation of the emergency paging system must obtain an STI level of 0.6 and also must be 10 decibels above ambient, with a uniformity of plus minus 6 decibels. So we need to hit that. We've got to be designing to hit 0.6 STI at the least. Plus, we've got to be thinking about the power, because it has to be 10 decibels above the ambient. So if it's 80 decibels in this room right now, the least amount that needs to hit my ear in order for it to be intelligible is 90 decibels, because that's the minimum amount for it to be intelligible. 10, that's really minimum. 10, it should really be better than that, but you know, often you'll see that in a tender. So it's very important, STI, obviously, for emergency announcement, because these announcements could save a person's life. So STI is very important, and we can measure that. So we use EASE and EASE EVAC software, and we are able to calculate by inputting what the room is like, how many speakers we have, what we're planning to tap the speakers at. We can measure STI. So for instance, here we have a 100-foot long hallway, 10 feet wide, 12-foot ceilings, drywall on the walls and ceiling. It's got a carpet on the floor. So, pardon me, there's 60 dB ambient. We're planning to put 7 speakers in here at 1 watt each. And we have this 0.6 that we're trying to hit, 10 dB above ambient. So our when we do this, you can see that we're hitting 0.72 there, which is great. And we are over ambient by a good amount as well. So that's perfect. So for that hallway, excellent. We can move on. If the hallway was concrete floors, drywall on the walls and see, but the floors are concrete, there's still that same ambient. We've still got the same number of speakers, but you can see we're hitting only 0.5. We've got a lot of problems with reflections, different things like that. So we have to think about how can we improve that. One way you can improve it is by obviously adding carpet, right? That's an absorbing, that absorbs sound and can help with reflections. Or you can put acoustic panels in that space if that's a very important space and you want to hit 0.6 at least. Plus, you can add more speakers. This is not a bid to make more money, but this improves STI. More speakers, lower tap setting can help to make sure that they are hearing the announcement properly. So we take it, when we're designing, we're thinking about all these different things, relocating the speakers, how many there are, the tap settings. We're trying to think about all the pros and cons when we're putting together a system. With warehouse, there's offices out front in the office area. We're thinking about it's a large open area. It's low ceilings. The office is the person buying the system is very price conscious. We have to take that into consideration as well. We're going to use our PC 580s with that BB 580 back can. It's a T-bar ceiling, so we've got our tile rails in there. And we space out a system. It's low ambient, as I've mentioned. We want to make sure that we're intelligible in the office space, and we achieve that. But now the warehouse, when we're thinking about that, we've got a lot of other things in there that you've got to think about. Tall ceilings. I've been in some warehouses that are 40 feet high, but more often than not, the typical is like a 24-foot to the deck. You've got tall racks, not quite to the deck, but almost. The racks are full of cardboard, right? Full of boxes, which act as they absorb sound. So that's good and bad in some cases. You've got these narrow aisles, so you're in this very deep valley. How do I reach that person in that very long aisle, surrounded by cardboard? The aisle's only what, 8 feet wide, and they're down there. How do I reach them? So you've got to think about really focused high SPL speakers. Maybe our SC630 you see on the top there. Maybe the CS horn that you see there. And we lay it all out, and then we make sure that we hit what's required. We've taken note of the ambient, and we make sure that that person in that long aisle can hear us. And we take those measurements. You can see there's little dots here. These are as if people were standing there. You can see this green dot here. This person is receiving almost 80 decibels, or pardon me, almost 75 decibels, 74.9. Whereas this person, he's more on axis. He is receiving 84.6 decibels. I've got to get better glasses, my gosh. But we've been able to achieve that because the horns are very sensitive. These SC horns, especially 113 decibels at 1 watt, 1 meter. So they're lots of power to give. We can also provide riser diagrams when we're doing our layouts and when we're working on a design. So in this particular one, you can see moving from the left to the right, there's a SIP phone system. So we have our A9060 DHM2 as a mixer amplifier. It's got a module, a SIP module to accept that so that they can page via their SIP phones. The 60-watt amplifier in there is taking care of that zone with the PC580RU at the bottom. But also we have an output from our A9060 mixer going to DA250 FH 4-channel power amplifier that will handle other zones, 4 other zones. And so you can see here the mixture of there's the SIP module at the top of the picture there. There's a noise masking module, as well as that's the A9060 and the DA250 FH. When you're even working in a larger system, you may need even, a larger facility, you may need more speakers or even change the speaker again. You've got taller ceilings, the distance on the aisles. If you're thinking about, I'm thinking about big warehouses like, I don't know, Amazon, or I don't know, just trying to think of huge grocery store warehouses. You're really in the high, speaking of grocery stores, so I was working with a grocery store company, and they had a distribution center, and the ambient was very high because that particular building was refrigerated. So the refrigerators are roaring, and they just couldn't reach out to their own people in the space. So I suggested the HA1010, which is an array of horns in a narrow rectangular box, about 4 feet high. And when you put things in an array, it gives you a very narrow distribution. You have great control over the vertical. It covers it nicely, 90 degrees, but it's only 15 degrees in the vertical, and it's able to throw very far. And as a result, they were able to reach out and touch all areas. So it just depends on the speaker that you're using, and you got to choose the right one. This one, we just used a lot of SC horns. It just worked out better, and we were able to provide the coverage that they were looking for. And here is the riser diagram of that particular place. It's not noted, but I'll just take you through it. So the top box is the TT104B timer connected to the second small box underneath, which is the EV20R digital message repeater. That's connected below it to an M9000 mixer, which then puts out all of that information to 3 different 4-channel power amplifiers, DA500s, and they are able to take care of 11 zones. So that is another way to do it, and they're paging obviously with that microphone. Sports complexes are also another facility that can be very tricky, because you've got a number of different spaces that are very different. You've got an arena, an ice rink. Maybe you've got pool, big Olympic-sized pool. That's another area entirely. They cannot use the same equipment all the time. Maybe you've got a gym. Maybe you've got community rooms that can be used and rented for different functions. All sorts of different things going on. How do you do that? So we've got to really use the equipment that meets each room. So we often do clusters in the center ice using our HX7. You can see that 4-speaker array that's there, sort of looking like an accordion. We could put 4 of those at center ice, or if it's a really large arena, we could hang them to cover the not only the ice, but we could cover the audience areas as well. We will need a variety of speakers, and you can see this diagram is pretty small, but I can take you through it. The top left, where the head end is, we have a mixer amp, and all of the sources that we need, the microphone, background music. There's different sources where we can connect our own devices for music. That's all at the head end. Plus, you'll notice it also is caring for a small zone with ceiling speakers. From the head end, we go out to other subsystems, and we're able to announce to the entire facility. The aquatics area has, you can see, a number of arrays. These are probably HX7s or HX5s, the weatherproof version, with a number of subwoofers. There's 2 4-channel power amplifiers in there. There's a couple of remote wall plate mixers where the end user can connect their devices for music if they happen to be renting the pool, or if there's some sort of exercise class there, they can put on music locally. But all of the announcements from the head end will jump in and take priority if there's an emergency. Same with the fitness area. Fitness areas are tricky because one class could be spinning, a spinning class. They want heavy driving music, get everybody motivated. But the next class could be yoga, and it needs to be a lot calmer. So you've got to think about that when you're selecting the equipment that you're putting in there. Same with the gym, different demands. You can see they've got arrays in there too, subwoofers. Each sub has its own channel. There's another smaller room there with ceiling speakers, more wall plates so that the end users can use their own devices. But they're all connected to the head end, so you can have a larger paging system. And if there's an emergency, everyone can be contacted. So mass notification is a term that encompasses everything, not just speakers and audio from us, but it can be digital signage, it can be text to speech, it can be text messages to staff's phones, all these different things. That's mass notification. What we're providing is emergency communication system, emergency paging, and that's where our VM3000 comes in. The VM3000 is complies both with the American UL 2572 standard as well as the Canadian ULCS 576 for mass notification products. You can have a combination of first responder mics, like the fireman's mic you see on the front of the black VM3000, but you can also combine it with 2 remote mics, up to 4 in total. You can have, it has a built-in emergency, a built-in digital message repeater that can have everyday messages, but also emergency messages. You can configure everything with the software that's provided. You can do zone setting, priority settings. You can have settings for failure detection, monitoring the speaker lines, and it all comes up on that LCD screen just next to the right of the red button on that VM3000. The VM3000 box that you see there with the fireman's mic is 240 watts that you can share over 6 zones. If you need more power, you add the VM3240E, the extension box, which is below it, another 240 watts, another 6 zones. So you can keep adding until you have 10 boxes, 60 zones, 2400 watts of power that can provide emergency announcement to the facility, but you can also have background music. So if this was a mall or if this was a facility where you want to have background, you can have that, and you can have everyday messages, and you can have live messages for every day, oh, it's somebody's anniversary, whatever. But when it comes to the emergency, everything else is muted, and the priorities for the fireman's mic and the other mics that we discussed are set, and the fire alarms are going off, and it becomes an emergency announcement system. Here's some snapshots of the screens for the settings, in the VM3240. You can see on the left, it's outlining all the different zones. So you can name those zones, and you can see what's connected to this system, the 2 microphones that are connected. You can see the additional 3240E boxes that are connected and their 6 outputs. Plus on the right side and below in the blue, that's the priority settings screen. So maybe your priority will be the fireman's mic. That's number 1. And then the remote fireman's mic, that's number 2, and so forth. And then way down at the bottom is the background music. That's the last priority. So you can set all these different priorities out. We have a sheet just for mass notification that you can download. And you can check off all the different things that the end user is asking of you. And you can include all that information for us, just like the other sheet that you could download. Room dimensions, if you have floor plans, that would be excellent. And you can let us know what is required and then email that to us, and we can get working on your design. So we can do that too. Really appreciate you attending today. I hope that was informative. Good grief. And if I can be of any of assistance to you at all, please let me know, or just call our office or your local RSM. I work in Ontario, of course, but we've got regional sales managers across the country. Are there any messages? Are there any questions at all that I can help you with? Hopefully. Yeah, I have a question here from my office. Maybe it came from you guys, but it was asking about if you have a campus and if you have multiple buildings, and how is that configured? We can do that too. So if it's just for paging, we could actually make use of the customer's network, and we actually have audio over IP interfaces that we can use so that we could send the announcement from building 1 to buildings 2 and 3 as well, and connect with their head ends, their local head ends. If it's emergency announcement, we could work on that as well. We might have three different locations, but 3 different racks that are set up, but we can connect them also as well. Let me just see, I'm just getting a note that don't think there are any questions, which is fine. Oh, pardon me. I see one here. How do vaulted ceilings affect sound reflection? They do. And what we can do is help you with proper placement of speakers. And often we can use, I'm just thinking about how you can use arrays. Vaulted ceilings, maybe it's house of worship. Maybe it's, you know, gyms, large architectural rooms like that would, it's really a good idea to use arrays in those spaces. That's the first thing off the top of my head, because, you know, arrays really allow you, as I mentioned with the HA1010 horn array, it's really like, if a regular conventional speaker is like a conventional light bulb sending light everywhere, an array is like a spotlight, and it can send the sound where you need it to go. And I think arrays in large churches, airport terminals, I don't know, I'm trying to think of crazy buildings. That is perfect, because your audience really is down here. It's not, you know, not in the ceiling or anywhere else. So why energize the space sending the program to the ceiling when really you're just trying to address the people, you know, walking around in it? So why not have the array and utilize the array and send the sound to the audience? So that would be a good way, a good start anyway, to get past a vaulted ceiling and some other architectural challenges, and be able to send sound to where the people are. That'd be a good way to start. Plus, we could use our Ease software to help you with that as well, and see how we could place the speakers and where they need to be, and take into consideration a bunch of other factors as well. Thanks, everybody. Have a good day.